Hey, ladies and gentlemen, thanks for coming back again for another science lesson. We are talking about energy transformations. If you haven't seen this lesson, please get your packet out, copy down the notes, listen to the instruction, and enjoy science. Let's talk about energy transformations and what that is all about. Please watch the video and have fun.
Now on to the topic at hand, the conservation of energy, and energy in general. So the law of conservation of energy states that in a closed system, that is, a system isolated from its surroundings, the total energy of the system is conserved. Or, more loosely stated, energy cannot be created or destroyed, only transferred or transformed. This is also known as the first law of thermodynamics. So what do I mean by cannot be created or destroyed? If a bomb explodes, it's creating energy, right? And if a ball stops rolling, its energy must have been destroyed. Well, no. Because energy cannot be created or destroyed, only transferred or transformed. Let's talk a little bit more about energy. The SI unit for energy is the joule, named after James Prescott Joule, and there are different forms of energy. I'm going to talk about 5. Number 1 is kinetic energy, and is probably the energy you're most familiar with. This is the energy of motion. So any object moving through space has kinetic energy. This includes a ball thrown through the air, a swimming fish, and even a space shuttle flying through space. Number 2 is potential energy. This is the energy that an object has due to its position relative to some reference point. So a book set on a shelf has potential energy. A ball at the top of a hill has potential energy. And in both cases, they have potential energy because it can be easily converted to kinetic energy, right? If the book falls off the bookshelf or the ball rolls down the hill, we're taking that potential energy and converting it to kinetic energy. Number 3 is chemical energy. This is the energy stored in chemical bonds and released through chemical reactions. The bomb example I mentioned earlier is not energy being created, but energy being transformed from chemical energy to thermal energy. Photosynthesis takes solar energy and converts it to chemical energy. So the energy from the sun is literally being stored in chemical bonds within plants, which is pretty sweet. Number 4 is electrical energy. This is the energy due to a separation of charges and flow of electrons, also called an electrical current. All your household appliances use electrical energy and convert it to some other type of energy. For example, your blender converts electrical energy to kinetic energy to spin the blades. Your toaster converts electrical energy to thermal energy to toast your bread. And finally, number 5, thermal energy. So this is the energy given off as heat. When you start a campfire, you're breaking chemical bonds in the wood and transferring the chemical energy of those bonds into thermal energy and fire. Right? Friction is another example. So when a ball is rolling across the ground, there's friction between the ball and the ground. This friction slows the ball down, but it's actually that kinetic energy being transferred into thermal energy, which is then dissipated into the ground. It's also why you can warm up your hands by rubbing them together, because you're taking kinetic energy in the movement of your hands and converting it to thermal energy through the friction. So those are 5 types of energy that you should be familiar with. There are others, but those are the main ones. And all those examples illustrate the law of conservation of energy, which is that energy cannot be created or destroyed, only transferred or transformed. I hope this video helped you and you enjoyed seeing my face. If you're not a subscriber already, please do so now and check out my other videos. And if you have any additional questions, please throw them in the comments.
So as you can see, this lesson is going to be about different kinds of energy and how they transform from one type into another. All right, let's talk about what's going on today. You're going to need your note packet. We also have some project work time because that project is coming due next week, February 5th, about the energy in the news essay. Here we are in our packet talking about energy transformations. Energy can change from one type into another. For example, as we saw in the video, chemical energy can turn into kinetic energy, such as in a bomb or something like that. Or if you burn something, a piece of wood, as it's burning, it can create a lot of thermal energy, which is a form of kinetic energy, the motion of the molecules heating up. Chemical energy can be stored in food, released, and turned into kinetic energy for your moving arm as you take your notes right now. Pause if you need to. Let's draw a simple cartoon in your notes that shows a series of energy transformations. You can choose the types you want, but let's have a challenge where we end at thermal. What do I mean by that? Well, let's talk about the chemical energy stored in this ice cream cone in the bonds of the sugar molecules. When you eat it, it can be converted in your body to motion as you pedal the bike. The bike has moving mechanical parts. As they rub upon each other, they get thermal energy. That's friction. A lot of energy ends as thermal energy and dissipates into the universe and just spreads out. It doesn't go away, but it just adds to the universal background radiation of the universe. And often we say that's where energy goes to die. However, it didn't ever disappear. Energy is simply transformed. Go ahead and pause and try to draw a simple cartoon to show an energy transformation of your own. See if you can end it as thermal energy. Okay, the law of conservation of energy is a law in physics that states energy cannot be created nor destroyed, only changing forms. As we've been saying today, the energy from a battery, for example, changed from the chemical energy into, let's say, electrical energy, powering something. When your battery dies, it didn't lose its energy, it just converted its energy into something else. This might be the Bob.
Been brushing and flossing your teeth, keeping them
physics.
nice and healthy, huh? Not going to do much good if this 14-pound ball come crashing through them, yeah? Watch this. I want to show you a nice physics demo. The ball doesn't smash my teeth. How come? How come? Because of a very important conservation principle called conservation of energy in physics, which states this. Take some energy to lift the ball, yeah? Now it has energy of position. Call that potential energy. I let go, it turns into energy of motion, kinetic, back to potential, kinetic, motion, but no more potential energy afterwards than that which I start with. Try this sometime. Give the ball a little push. You better move your head. You know why? Because you gave it some energy in addition to the potential energy, and it will come higher.
Okay, that being said, the law of conservation of energy says energy can't be destroyed. So if you drop a basketball, it eventually stops bouncing. Why? I thought the energy was never going to go away. According to that law of conservation of energy, it should be the same. It should bounce up to the same level. Like when he released that bowling ball, it went, came back, no more than it started with, but came back to just about the same point where he let go. If you swung that bowling ball and just let it go, would it always come back to the same height, or would it eventually slow down and stop? Why? Eventually would slow down and stop. In fact, when you bounce a ball, you lose about a third of the energy each time. Where does the energy go? Pause the video, stop and think about it. Ball bouncing, here we go, ready? Where's the energy going? Let's hear it again. Here's the ball bouncing. That's right. The energy turned into a different form of energy called sound energy. Okay, so it's also some kinetic energy involved in the hitting of the molecules on the desk or wherever you bounce the ball, and that can turn into friction and thermal energy. So in the case of swinging the bowling ball on that string, there's a little bit of thermal energy and friction through the air, and friction at the point where the rope is attached, and eventually that pendulum stops just like a bouncing ball, but it didn't lose its energy, it actually converted. In the case of the ball, it's sound energy. All right, draw the energy conservation flow chart. See if you can maybe do 3 or 4 cartoons somewhere on a piece of paper where you talk about energy turning from one form into another. I don't know, you could start at nuclear energy in the sun. That energy turns into electromagnetic energy of light, which powers the process of photosynthesis for a plant, which maybe provides chemical energy such as sugar, which can be eaten, and provide kinetic energy and movement, which also creates heat. Okay, so I've connected them all. Go ahead and see if you can connect some different forms of energy. All right, guys, don't forget, working on your project energy in the news. Get your outline done by Friday and get your final project done by the Friday after that. And, of course, make sure you know your energy transformations and all the things we did today on our notes and so far that we've done. If you haven't checked out those online lessons, make sure you're coming to class every day, joining the live streams, and don't forget, thanks for trying science. See you on the next one.